Welcome to Tech Repair Guide. In this video, I'll be going over diagnosing and repairing a faulty DC alternator. Now let's jump right in. As you will see on the generator screen, the battery voltage is shown 23.1 to 23.4, and this is after both batteries on the generator set had been replaced due to low voltage. Upon noticing that the battery voltage was still low after both batteries were replaced with new batteries, then the problem had to be elsewhere, so I decided to check the DC alternator to see what it was producing. The DC alternator was putting out 25.3 to 25.4 volts, so this in return told me that the battery charger was not putting out any voltage because this is the battery voltage at rest, because the cables are still connected going from the batteries to the alternator, DC alternator, then going to the remaining DC circuits. So upon disconnecting the positive cable going to the battery charger and no cables connected, I noticed that the DC alternator was not putting out any volts. So the DC alternator is also, or another name for the DC alternator is called the battery charger. So upon this discovery, I decided to replace it with a new DC alternator. On this specific generator set, the DC voltage is a total of 24 volts, and the alternator, the DC alternator, also referred to as the battery charger. From now on, I'll just refer to as the DC alternator as the battery charger. So the battery charger in this unit is a total of 28 volts. So this is one of the reasons why I could tell that the battery charger was faulty, because it was producing 25. It was producing between 23 to 25 volts, or that's what it was displaying. So that tells you something is wrong, because the battery charger itself should produce around about 27.5 to 28 volts thereabout. I then went ahead and removed the old battery charger, and now I'm taking the pulley off, and also the black thing that I'm taking off right now, it is used to cool the coils inside of the battery charger. So basically, while it spins, it produces, or it pushes air down inside the core to cool all of the elements inside of the battery charger, basically. So all I'm doing is taking the pulley and the fan basically from the old one and putting it to the new one. Normally you will notice that some battery charger upon purchase, they come with the pulley already on it and also the thing to cool it. But for this specific one, it didn't come with that piece. So basically I just gotta switch it over from the old one to the new one. Normally you will find a battery charger on various equipment. So basically they're on like generators, they're on cars also. So all they do basically is they produce voltage towards the DC circuit. So basically, say for instance a car, right? While the battery charger is turning, it produces voltage towards your radios, your lights, and stuff of that nature. So basically that's the purpose of a battery charger. So within a generator system, basically what it does is, so the batteries are used at rest. So basically when the generator is off, the batteries are used to turn the generator on, so to power it, the DC circuit. And then once the generator is turned on, the battery charger, DC alternator, then takes over to start powering all the DC circuits and also charging the battery in the meantime as well. So now I'm getting ready to reinstall the alternators. Normally the alternator it depends on the specific unit. Sometimes they are pretty easy to install, and sometimes they take a little bit more, or they're a little bit more difficult based on the pulley. So right now, basically what I'm trying to do is get a hold of the fan belt and trying to basically put it over the pulley so it'll be aligned. Now that the belt is all seated on the pulley, now you want to go ahead and basically tighten or secure the battery charger. Normally there's a total of two bolts that normally holds the battery charger in place, one at the bottom and one at the top. On this specific unit, the one at the top, the bolt is placed between like a bracket basically. So basically you could either push it forward to release tension or pull it back to create tension. So normally whenever you install a battery charger, you want it to basically have a tension. You don't want it to be too tight or too loose. If you have it too loose, it will not spin fast enough. So basically it will not produce the amount of correct voltage. It could produce lower voltage than intended. And also if you put it too tight, then it'll create a lot of strain on the fan belts. Sometimes it could actually tear the fan belt or create tension on the fan itself. Also, another reason, if the belt is too loose, it will also create a slippage. So that's one of the reasons. Also, the battery charger won't produce enough volts to power the DC circuits. After you're finished securing and connecting everything, you want to go ahead and check the tension of the fan belt. So by doing this, you're checking to make sure the belt doesn't pass a half-inch deflection. So you don't want it to sink more than half of an inch. So that's what I'm checking right now. So once everything is good, that will tell you, once it's within the half-inch ratio, that's telling you it's not too loose and also it's not too tight. So you're good to go, and you could go ahead and test your unit. So now I'm about to put all the cables back. I'm gonna install all the cables back on the battery charger, and then we could go ahead and test this unit to see if it's operating correctly. A good safety tip to follow is whenever you're checking the fan belt for the tension, that a half-inch deflection, you want to press on it with the back of the hand. Basically, the reason why you do this is, say for instance, if the generator was to start up, right? Basically, the normal human reaction is to grab onto something. So basically, you pressing on it with the back of your hand, you wouldn't be able to grab it, and you could actually be able to take your hand away. But normally, in the first place, if you were working on a unit, the generator set, you want to follow good safety practices. So you want to make sure the unit is turned off, the batteries are disconnected, and there is no means of this unit starting basically. Right now I'm connecting your positive cable, and this is where your DC voltage comes from, going towards your DC circuits. On this specific battery charger, you only connect the DC cable on this specific battery charger. the negative cables are connected on a different tap basically. Now that I'm almost finished with connecting all the cables, all that is left to be done is basically check the system to see if it's producing the proper voltage. So basically what we're going to be looking for while we're doing the functional test of this generator system and the battery charger, basically you want to see coming directly off the alternator, the DC alternator, you want to see anywhere between say 27, 27.5 to 28 volts, and this is DC. So that's what we're looking for. That's the correct voltage that we should get, because this specific battery charger is 28 volts. So that's what we should see. So now that we have connected it, now we are actually seeing 27.9. So that is actually pretty good. You can see the fan belt right there, as in the engine is currently running. So we are getting the correct volts basically. So now we're finished. So now on the screen, you could see the battery voltage. So it's showing a total of 20, from 25.8 up to 26.1. So you're seeing that it's charging, because before it was showing 23 to 24 volts.